Good morning. So today we are going to see a topic in communication network, that is 6LoWPAN, a wireless extension of the internet. 6LoWPAN. This is means it is an IPv6 over a low power wireless personal area network, and this is a networking technology or adaptation layer that IPv6 can be applied even to a small link frames that is given by IEEE 802.15.4, and it is an open standard that is defined in RFC 6282 by IETF. And the important feature of this 6LoWPAN is designed to support IEEE 802.15.4 in 2.4 gigahertz. And but now it is used in various networking media like Bluetooth, low power RF, Bluetooth that is smart and low power Wi-Fi, etc. And this is the 6LoWPAN network architecture. So here we can see it is it consists of an embedded wireless islands, that is a internet that will be created by number of islands which contains a sub network on the internet. So overall our architecture is given in this figure. You can see the figure in which in the internet we are connecting through edge router. We'll be connecting the simple LoWPAN, next one the extended LoWPAN, next ad hoc LoWPAN, etc. Okay, here we are having a sub network, that is a network in which the IP packets are sent from and destined to, but it does not access and transit to the other network. So the 6LoWPAN, it is made up of low power wireless network with IP V6 subnet network. So we are having three different kinds of LoWPANs, that is simple LoWPAN, extended LoWPAN, and ad hoc LoWPAN. So a LoWPAN, it is a collection of nodes which will be sharing a common IPv6 address prefix of a node in which this LoWPAN in a LoWPAN, its IPv6 address will be same. A simple LoWPAN is connected through one LoWPAN edge router to another IP network. Backhaul, it contains your point-to-point link. So one example is GPRS. Next one, backbone link, which represents a shared link. And extended LoWPAN, it encompasses a LoWPAN of multiple edge router along with a backbone link interconnecting them. LoWPAN connected to other IP networks through edge routers. So edge router routes the traffic that is in and out of LoWPAN, and it is also used for management function, overall IT management solution. And multiple edge routers are used. They will be sharing a common backbone link. A LoWPAN consists of nodes which play a role of router or host along with these edge routers. For an effective network operation, network will register with an edge router. So here neighbor discovery, that is represented by ND. This refers to host and router interact with each other on the same link. So LoWPAN nodes participating in more than one LoWPAN at the same time is called as multi-homing. And multi-hop mesh topology in LoWPAN, it can be achieved through a link forwarding or using IP routing. So each LoWPAN will be identified by one unique IP address, and it will be capable of sending both sending and receiving the IPv6 packets. So this this LoWPAN nodes will be supporting ICMP v6 traffic, that is such as ping, and use UDP as a transport protocol. So about a simple and extended LoWPAN, simple and extended LoWPAN can communicate through edge routers. So difference between two is the existence of multiple edge router, and also it will be sharing a same IPv6 prefix, also a common backbone link. So multiple LoWPAN can overlap with each other. A LoWPAN edge router is typically connected to the internet through either cellular or DSL connection, and this does not require any infrastructure to operate. So ad hoc LoWPAN, in ad hoc LoWPAN, one router must configure to other act as a simplified edge router, and it implements two basic functionalities. One is a unique local unicast address generation, and also handling 6-LoWPAN ND, that is enable discovery restoration functionality. So next is about the stack system overview of this LoWPAN. 6-LoWPAN radically changes this IoT environment. So it is in devices such as Zigbee, Bluetooth. This all needs a complex application layer to connect to internet. So this can be solved by using 6-LoWPAN by introducing one adaptation layer that is between the IP stack link and network layer, and it will be enabling the transmission of IP datagram over this IEEE 802.15.4 radio links. So this shows an OSI model, a Wi-Fi stack example, and a 6-LoWPAN stack. So first we can see the simplified OSI model. So here we have 5 layers: physical layer, data link layer, network layer, transport layer, and application layer. So next shows one Wi-Fi stack example, and next shows one 6-LoWPAN stack model. So first is the physical layer. So physical layer will be capable of converting the data signals, and it will be transmitted or received through air. So here we are considering two important standards. So one is the IEEE 802.15E and IEEE 802.15G. So for E, it provides enhancements such as time slotted channel hopping and coordinated sample listening. And for G, it aims to provide an additional range of RF bands to enable an use of sub 1 GHz frequency bands. So data link layer, this data link layer provides one reliable link between two connecting devices by detecting and correcting errors that occurs in the physical layer. And data link layer includes our MAC, which provides access to media using CSMA/CA. This layer also handles data framing. So adaptation layer provides an adaptation from IPv6 to IEEE 802. So network layer. So network layer, it addresses and routes the data through network over several hops. IP means that is the interneting protocol is used to provide all devices with IP address to the transport layer. So next is the transport layer. So it will be generating communication between the application layer, applications running on the devices, and it also allows multiple applications on each device to have their own communication channel. And TCP dominant transport protocol. TCP is a dominant transport protocol on the internet, and TCP is a connection based protocol, and UDP is a connectionless protocol. So application layer is responsible for data formatting. So application layer, this HTTP is running over TCP, and HTTP uses a XML protocols, and industrial and the community has a alternative protocols such as constrained application protocol, COAP. So next is the adaptation layer. So adaptation layer for sending the data over MAC and physical layer, adaptation layer is used. So for 6-LoWPAN, it defines how IPv6 data frame is encapsulated over IEEE 802.15.4, and the main focus of this 6-LoWPAN was to optimize the transmission of IPv6 packet over low power and a lossy network. So header compression, we are compressing the 40 byte compresses 40 byte IPv6 and 8 byte UDP headers by assuming the usage of common fields. And next one is the fragmentation and reassembly. Next is the stateless auto configuration, and device inside this 6-LoWPAN generate their own IPv6 address. This method avoids duplicate address detection. So this is the header compression. So first given is the IPv6 header. It is a 40 byte header. So next is the compressed header, that is a 2 byte. Next shows the compressed header for of 12 byte, and third one shows some compressed header for 20 bytes. So header compression is status based. If a point connection, it uses a stable link. If multiple hops, if there is multiple hop, then hop by hop compression or decompression. So routing protocols running in a LoWPAN system obtain diversity by rerouting with reduced compression efficiency. So header format. So 6-LoWPANs use a stacked header, and it is similar to IPv6 extension header. So IP6LoWPAN header defines capability of each subheader. Subheader defined are mesh addressing, fragmentation, and header compression. So mesh addressing, it is the support layer on the uh, to forwarding and fragmentation support the transmission of IPv6 MTU, and fragmentation header is omitted for packets that fit into a single IEEE 802.1.15.4 frame. So it contains three fields. One is the data size, the total replay payload. Next one is the datagram tag. It identifies set of fragments which and matches the fragments. Datagram offset, it identifies fragment offset within unfragment payload. Mesh header includes three fields, that is one is the host limit, source address, and destination address. So next one is the stacked header. So we can see the 6LoWPAN stacked header. So in first we are having the header, next one IPv4 header compression, and IPv6 payload. So next shows one fragment header and also header compression. So in the last format we can see one mesh address header is also added along with fragment header and IPv6 header compression. So what are the challenges in the 6LoWPAN? So first one is IP connectivity. As the node increases, the necessity for network auto configuration can be achieved through IPv6. A limited packet size, that is application using 6LoWPAN support only small packets. Limited configuration and management. And next one challenge is service discovery and security. So next one is the localization. This provide information related to nodes. 6LoWPAN possesses certain challenges such as failure to node due to lack of power, interference, and also interference will be leading to rerouting and reorganization of the network. So these are the challenges in 6LoWPAN which can be overcome in the future. Okay, thank you.